Excellent, excellent. Well, welcome everybody. I'm Dean, KK4DAS, Vice President of Vienna Wireless Society. This is the regular meeting of the Vienna Wireless Society for July 9th, 2021. Got a bunch of people here. We have a terrific program. And with that, I want to turn it right over to Steve at KO4KGS, who's got a presentation for us on the worldwide microchip shortage, which is what I can tell you from a homebrew maker perspective has already hit us in the homebrew market, because we can't get some of the chips that we used to be able to get for the builds that we're trying to do. So Steve, go ahead.
What a real treat to present on this topic to my ham radio club. This topic of the global semiconductor crisis is certainly one that has manifest no shortage of hand-wringing in the consumer technology industry, but more broadly, really across the economy. Now, why do I say that? Well, the simple fact is that these days we're putting bits of silicon and microcontrollers in just about everything. So this is truly an economy-wide scenario that has captured the attention of the administration and policymakers and so forth, and this is also globally. But is also filtered down to, as Dean was saying, to our hobby, our favorite hobby of ham radio. So how did we get in this crisis, this fix in the first place? What is happening now? And most importantly, how do we get out of this corner that we have ostensibly painted ourselves into? Well, these are some of the questions I'm going to endeavor to answer in the short program this evening. But before we do that, if you'll just indulge just a little bit more commentary about myself. So I feel like I need to introduce myself because my call sign, my Kilo Oscar 4 call sign is a dead giveaway. I am a new ham. I have enthusiastically leaned into the hobby, had a lot of great mentors, too many to name really, but one of my favorite parts about the hobby is pictured here is field day. I've really enjoyed field day activities, and shown here, I'm feverishly scribbling down call signs and designations. I was essentially the GOTA, or get on the air goat. I was the goat. With my newness to the hobby, I qualified, and so we were using Andrew's call sign, K3NHT, and his call sign has been pretty much tattooed in my brain because I logged, I'm pleased to say, over 100 QSOs for GOTA, scoring hopefully a bunch of points for the team. But apart from that, in my professional life, I work for Consumer Technology Association. CTA is the North American Trade Association for all consumer tech, which is to say everything from an iPhone to a Mercedes-Benz, and our membership constituency really reflects that. We have not just tech makers and retailers, but really all kinds. John Deere, as one example, is a member. And my role is really leading the research function at CTA. I've worked at CTA for 17 years, and research is definitely one of the things that distinguishes CTA in the trade association world. In fact, we do a lot of economic forecasting, industry forecasting, of course, but a number of consumer and B2B studies, probably 25 or 30 each year. It's a lot of work, a lot of research, but a lot of fun because there's always something new to talk about in consumer tech. But apart from research, one of the things that CTA is best known for, in fact, probably the thing we're best known for, and might ring a bell for several of you, is CTA is the owner and producer of CES, the Consumer Electronics Show held each January in Las Vegas. And I know that some of you have actually, in your careers, have attended CES, but pretty much everybody who enjoys electronics desires to make at least one pilgrimage to Las Vegas to attend CES, and it's well worth it. This is a snap from 2019, but our 2020 show just before the health crisis struck. CES is the world's largest technology event, and it's so much fun. We had in 2020, January 2020, about 3.2 million net square feet of exhibit space. That's just exhibit space. That's not counting aisleways, pathways, and hallways. So truly massive. And even more massive are the number of attendees. About 170,000 trade professionals from over 150 countries attend CES, at least in a regular season. And we will be back in person in Vegas in January 2022, I'm pleased to say. But like I said, it's a lot of fun. There's so much to see, so many innovations. Just pictured here is just a taste, a very, very small taste. Robotic kitchens in the bottom right. Air taxis, flying cars, or their proper term is electric vertical takeoff and landing craft, pictured there in the bottom left. This is a partnership between Hyundai and Uber. In the top right, Samsung has the largest footprint that we allow at CES. Therefore, attendees commonly refer to Samsung space as Samsung City. Obviously, a big brand in tech, lots going on there. And then lastly, in the top left, this is LG always does this array of OLED panels that is just truly mesmerizing. And with the black levels you can achieve with OLED, as you may know, it can kind of create some vertigo because it's just hyper realistic, almost VR-esque, if I might say so. So enough about CES. Maybe I can come back another time and talk more about some of the things that we're seeing at the 2022 show when that happens next year. But let me just start my remarks around the topic of this chip shortage with this quote from Dan Schulman, the CEO of PayPal. Now, Schulman's quote here is clearly tongue-in-cheek, but also very apropos when we think about the global semiconductor crisis and shortage thereof. Now, what is Schulman trying to tell us here? He's describing really the massive acceleration in tech adoption and demand that we've seen in this season. So across America and really globally, consumers have been funneling discretionary dollars into tech. We've seen just so many tech sectors advance, not only in adoption, but purchase intent. Services too. You may be surprised to know it really only took Disney Plus about 5 months to hit 50 million global subscribers. So clearly that's a function of a lot of people staying at home, but this is why Schulman's saying we kind of, not that we were living in the Stone Age, but yeah, it's kind of like that. We saw massive tech adoption. So this is foreshadowing one of the principal reasons that we're in this shortage is increased tech demand. But let's take a little bit of a closer look at the semiconductor sector. Now, I know this is a little bit dated information. This is the latest I could get from the Semiconductor Industry Association, but just shows you a view of semiconductor demand share by sector. And it makes sense, doesn't it, that communications and computing would together constitute the lion's share of global demand for chips. But automotive has its part. We know that cars today are like computers on wheels. Consumer has its slice too, of course, with that long tail of consumer devices that use chips from wireless earbuds, smart speakers, and TVs, and so many other things that connect on unlicensed spectrum and so forth. The orange pie of industrial, this is a space to watch because we think about industrial IoT and future factory automation. This is a big push this decade where 5G and AI are combining to automate a lot of processes and so forth, which is also a good point to mention on the note. You've heard the term IoT, Internet of Things, and actually that IoT is a little bit dated and really more appropriate for the last decade when we were really vis-a-vis 4G and broadband really getting everything connected. These days, I refer to IoT in a new way as the intelligence of things. Now, why do I say that? Well, it's because we've pretty well connected most things these days, but what we're really doing in earnest now is adding intelligence, which is, of course, AI. And that's not just in tech, but really across the economy, and particularly in the commercial and industrial sector. So demand probably increasing for chips in that sector. But let's lean in a little bit more to the semiconductor space and just kind of get reacquainted with kind of how we talk about semis. And it's really, when you're talking semis, you're talking across two dimensions that you can see here: feature size or node, and then wafer size. And let me just unpack both of these things briefly, because you're familiar, with the length of the gate. We refer to this in nanometers. Impossibly small. 5 nanometer nodes are pretty much table stakes, I would say, in the semiconductor chip business these days. But If you look into the news, and you can Google this, you'll find some very recent stories where IBM, also Intel, have developed a 2 or 3 nanometer process. And this is just truly remarkable. It's really almost like science fiction because the width of a strand of human DNA is 2.5 nanometers. So these are just impossibly small sizes, and it's very interesting, I think, to just think about the tremendous sophistication of these machines that make this stuff, that print literally billions and billions and billions of transistors on these tiny chips. So that's really incredible. We're able to crank out more chips because we've been able to print them on progressively larger wafers. 300 millimeters is the industry standard, I would say, today. Some makers use smaller wafers, but 300 millimeters, which is just under a foot, about 11.8 inches. And probably in this decade, we'll see that wafer size grow to 450 millimeters, which is about 18 inches. So even more chips, get economies of scale, that familiar term. We can just punch out more and more chips on each go. But there's been some innovation here. I talked about the 2 and 3 nanometer process. Because of this is really changing the nature of how we talk about chips. And what I'm talking about is really transistor density. And this is becoming, I think, because of this innovation, which if you look on the left side here, you see some descriptors here about IBM's 2 nanometer process compared with the standard 7 nanometer process. So you can see there's a pretty big gain, 45% performance gain at equivalent power. You can get the same performance at about a 25% savings in power. So that's a good thing, congruent with what we always try to do in tech, smaller, faster, lighter, cheaper. But really this conversation and how we talk about semis is switching over to transistor density because of 3D transistor design, which if we're talking 3D transistor design, we're talking FinFETs. So on the right, you can see an illustration of FinFETs and kind of the traditional planar FET, if you remember from your electronics training, and then this 3D process, which really has 3 sides of conductive surface. So this is a lot better, a lot more throughput. And again, just fascinating, almost sci-fi, but it's true, it's reality. So Leon, I see your 3D printing and I raise you a 3D FinFET. But this is truly, truly incredible. And maybe if there's somebody in the club that's better qualified than I am to talk more about this remarkable engineering. I'm not an engineer, by the way, but this is just some of the innovation that's just truly remarkable that's happening. Transistor density. So just a bit more about semiconductor. It's important also when we're thinking about the shortage, because supply chain is definitely part of that story. A very complex supply chain that you can see here, really starting with the wafers that I've talked about, and we get over to design and what's called front-end fabrication, which is where a lot of these transistors are etched. And some of that happens domestically. It also happens overseas as well. But in this illustration case, then we move overseas with these printed wafers to facilities like TSMC in Taiwan that really punch them out of the wafer and package them into their familiar shapes and sizes, as you can see illustrated here, and do all the back-end assembly, test, and packaging. And from there, of course, a lot of these chips go into what? Well, consumer technology products. And a lot of that manufacturing is naturally in Asia. And then those products are shipped to the United States and really worldwide. So really answering the question, so how do we get into this mess? Well, it's multifactorial in a word, and a lot of information here. So again, allow me to unpack this slide for you a little bit, just to talk about the multiple factors that kind of played into this state of affairs that we find ourselves in. The auto industry has been hit particularly hard, and really they shot themselves in the foot back at the headwaters of the crisis in the spring of 2020, when their forecasts, they were predicting that no one's going to buy a car in the middle of a pandemic, and they were horribly wrong. And we'll talk more about that. But in short, people were happy to funnel freed up discretionary spending into putting a down payment on a new car. Of course, politics is in everything these days, and certainly that played its role in this semiconductor shortage crisis. Tensions between the U.S. and China, tariffs and so forth, led to some stockpiling, made it difficult even last year for some of our member companies, particularly smaller players, to get chips. And then there was just kind of this series of unfortunate events. There were some factory fires in Japan at AKM and Renesas. It's never a good time to have a factory fire, of course, but right in the middle of a pandemic, when you're trying to get employees on site to run your production lines. And then, of course, you've got the Texas deep freeze, where Samsung operates a very large facility outside Austin, Texas, and that was shut down for weeks because of the deep freeze in Texas earlier this year. And then we get into supply chain and some of the various difficulties and constraints on multimodal logistics, which is to say kind of that sea carton, land, sea, air, train, maybe not air, but train logistics that are so common these days. And may surprise you to know that there's quite the queue of container ships outside the Port of Long Beach right now. Why? Well, one reason is a labor shortage. We can't get enough longshoremen there, but also it's just these disruptions tends to generate kind of these small armadas of container ships. It's like when they can get going, they get going, and then there's so many of them, they all kind of show up at once, and ergo, you have a lot of ships anchored off the California coast waiting their turn to come in and unload. But some of this stuff has been attributable to business management decisions, which is to say, really, I think prior to the pandemic, a lot of businesses were really managing for cost reduction. You've heard the term just-in-time inventory, very slick and expedient supply chains, but the pandemic essentially really just exposed how ridiculously fragile those supply chains can be. There wasn't a lot of risk management, and so therefore in the industry nowadays, there's a great deal of discussion in earnest around building more resilience in supply chains. Of course, the kind of the slogan "Never Again" is commonly heard. And this is certainly true, and a lot of thought being put towards that, certainly for smaller players. The big guys, they've got the clout and the dollars to do what they need to, but the smaller manufacturers, which really are the backbone of the domestic tech industry, these innovative companies and small players, small business, you guys get it, that they're really in a pinch. And many of them have been under pressure for over a year, not just recently. But there's more. But wait, there's more. Yes, all this season of buying everything online and certainly in the B2B space, the race to cloud, the digital transformation of the economy you've probably heard about. We've got to have more data centers. That requires more chips, as well as we're trying to build out the 5G infrastructure as quickly as possible to maintain American competitiveness. That takes chips. There are many more chips, in fact, in a 5G phone than there are in a 4G phone, simply because 5G operates, as you may know, across 3 different bands, essentially low, medium, and high. You've got more multiplexers and more microcontrollers for power. And so the system on a chip is very, very sophisticated, uses a lot more chips and so forth. And then you probably heard about crypto mining, and it's kind of like the tech equivalent of a grow room. You have these facilities where people will architect these arrays of GPUs connected to PCs to mine cryptocurrency. And so I don't know if you've tried to buy a higher end graphic card lately, but good luck. They're pretty short in supply. But really, again, as I said at the beginning of my remarks with the quote from Dan Schulman of PayPal, the thing that I really want you to remember is why did we get into this crisis, this shortage for semiconductors? It really has a lot to do with the historic level of consumer demand that we've seen in this season. So some economic data here, spending on durables. What are durables? Well, they're pretty much everything that's not consumable, like paper towels. And you can see some examples on the right: appliances, auto, certainly tech. But follow along with me here on the right. You can definitely see the dip with the 2008-2009 financial crisis, and then this very long and historic period of economic expansion that we had in the United States. So higher and higher levels of durable spending. And then the music stopped with the COVID crisis. But look at how spending just catapulted, and that's kind of the term I use here, the COVID catapult. And just grown even beyond kind of our wildest dreams, if you like, in terms of durable spending in America. Now, I know what you're saying. You're like, well, gosh, Steve, how is that even possible? Where are the dollars coming from? Well, a couple of things. First, stimulus dollars made millions of households across America suddenly feel rich. That was the perfect time for a down payment on a new vehicle, or buy a new TV, or get the kids new computers, you name it. And then secondly, in this season where we've been staying at home and we've abstained from a number of traditional behaviors, we've had a lot of freed up dollars that we're not spending on eating out, buying apparel, taking vacations. Not a lot of that happening over the past year, people getting on a flight to Hawaii or something like this. So we've channeled those dollars, and tech has benefited massively from that dynamic. And that's why there are a lot of questions right now is, will that demand remain elevated? We think so, because once you get a taste for technology, the convenience, the safety, digital health, and so forth, not a lot of people are like, oh, okay, yeah, well, that was good for a season, I'm done with that. They tend to want more. At least that's what our research shows. So essentially, the health crisis has really, like in the board game, sorry, instead of moving back 3 spaces, we've moved forward 3 spaces in terms of tech demand. And so what all this looks like and kind of what's happening now, well, look at some of this data from the first 4 months of this year in terms of lead times. Now, lead times are really that space of time from when you place your chip order to the time you receive it. Dean, maybe you're feeling some of this. It's like, yeah, I had to wait weeks for this certain chip or something like this. But take a look at microcontrollers, the red line. So January, 16 weeks, about a 3x increase in lead times in as many months. That's remarkable. And if you're a small business, a small manufacturer, this can be catastrophic. I mean, you can't really just furlough your factory employees and say, hey guys, well, I put the order in, I'm going to furlough you, come back in 44 weeks, and then we'll get busy, making the products. It's been very, very difficult. So what I'm saying is that a lot of the small tech companies here domestically and even globally, they've been managing business day to day. It has literally been a 7-day-a-week proposition, managing supply chain, doing spot buys to hedge against future disruption if they can get it. If they have good supply of a certain chip and more becomes available, they buy it because they know that something may happen. So how do we fix this? How do we get out of this corner that we've been painted into? Well, there's again, this is multifactorial and how we get out of this. And one thing we definitely need is more geodiversity of fabs. You may be surprised to know that almost 3/4 of semiconductor production capacity lies in East Asia, which is really China, Japan, Taiwan, South Korea. So what that means is, you guessed it, we're quite literally like one cyclone or tsunami or earthquake away from a massive, massive disruption in semiconductor production, which is why we just need more sourcing on the far right. So that's means building more fabs globally, which is where in the center public policy comes into the picture. And that has certainly been top of mind for the Biden administration, as well as the EU and other developed nations around the world. And here's what that looks like really in terms of the US policy development. If you remember, Biden signed this almost $2 trillion infrastructure investment, but I feel kind of silly saying this. Only $52 billion was really, it's a big amount, but against the number of 1.9 trillion, small potatoes to support domestic manufacturing, a lot of that going to chip making endeavors, already Intel and TSMC have talked about new facilities. Intel maybe building a couple of new fabs in Arizona, perhaps. But essentially what we're talking about here is public-private partnership to stimulate more investment and prop up the domestic production of semiconductors so that we can really secure our supply chain, because big tech is under attack right now. There was a new plan put forward today by the Biden administration, if you saw this in the news. But really, America's tech companies are the envy of the world. They're the envy of the world, Google, Apple. And if we want to keep it that way, we definitely need to shore up our supply chain as it pertains to semis. And so we'll see that happen, invariably in this decade. But there's really no easy fix. There's no easy fix. Now, why do I say that? Because Rome wasn't built in a day, and neither are semiconductor fabs. It takes about 3 or 4 years to build a single fab. That's a long time. So in the short term, we've seen producers adding production lines to the extent they can. I think most fabs are operating practically around the clock to really help meet demand and try to satisfy, at least in some part, most of their customers. But again, this longer term plan is we just got to build more factories, is what it comes down to, in the US and in Europe and so forth. But even with all this planned activity and constructing new fabs, when we look at projections here from SIA and Boston Consulting Group, projections moving forward for the share of semiconductor manufacturing capacity across different regions, including the US and China, for this decade, take a look at the black line, China. That's really the only one that's growing, and actually growing pretty aggressively. Everybody else is either in kind of a steady state in terms of share or declining slightly, like we see here if you lean into the screen a bit with Europe and the US. So concerning, yes. Is this going to be detrimental to the US? We'll see. But you can see certainly China has plans to build a lot more fabs and chip making facilities. In fact, by the 2030, probably 1 in 5 chips easily will be Chinese in origin. And so is that a bad thing? I don't know. But with their command economy, if they want something to happen, it's going to happen. And what they want to happen is build a lot more chip factories so that they can control more of the global market. And that's just a simple fact. While here in the US, we debate and argue, but we'll see what happens. But we need more fabs. So what about impact to amateur radio? Well, Dean had kind of talked a little bit about this at the micro level, at the individual chip level, but certainly this is a dynamic that is manifest across the economy, and like I said, filters down to our hobby of ham radio. And certainly on the left, there have been casualties already. On the left, the Kenwood THD74 was discontinued by Kenwood. So one casualty. Why? Well, because the chips that go in that were reprioritized for ostensibly higher margin products on the commercial side. At least that's my understanding. And many of you have probably experienced maybe some delays with some equipment, new gear that you've endeavored to purchase, whether it's an antenna tuner, I don't know, or maybe an oscilloscope. But those shortages are out there. But I think what we can expect for our hobby is essentially spot delays and shipments and some of these spot shortages across different brands and various segments. As I did this little screen capture from DX Engineering, and you can see here these Ameritron amplifiers aren't shipping until the middle part of September. But like the title says, I think you guys would agree with me, the new gear is worth the wait. It's if we can get this, we can wait. It's important that we get that and we get on air with our new stuff that we wholly endorse. So with that, that concludes my remarks. I'll say thanks in 73. And if there are any questions, I'm happy to answer them. And then you can question my answers.
Oh, fantastic, Steve. Thank you so much. Get on with our meeting. That's a fantastic presentation. I'm reminded of the old adage about when the best time to plant a tree is, and that's 10 years ago. So for those that don't know, I spent most of the last decade as a chief technology advisor in the federal government, and a big chunk of my time was spent advocating for more rapid development of semiconductor fabs because I saw this coming. This was predictable, and everybody saw it coming, and they didn't do anything about it. Frankly, our semiconductor industry bailed on us in about 1990, and they let the manufacturing all go overseas, and so we have no control. That's that's a very, very short version of what Steve's graph showed us. Anyway, but I think everybody's got the message now, and they're on their way.